Okay, so good afternoon, everyone. Welcome to this edition of the NITheCS Colloquium. Today, we are very lucky to have with us Professor Julian D, who will give us a very interesting talk on big data, blockchain, and butternut. Yeah. Julian is the director of the DSI NRF Center of Excellence in Food Security at the University of the Western Cape, and he also the UNESCO chair in African food system. Yeah? Julian is an economist by training and has worked on various topics that, and he will speak about some of them this evening. He's extensively published international and is also a member of several national expert groups, including the South African Statistics Council, the Council of the Academy of Sciences of South Africa, and he's been recently nominated to be a member of the 3rd National Planning Commission. So, Julian, we are really very happy that you accepted this invitation to give a colloquium for NITheCS, and I'm personally looking forward to start an engagement between NITheCS and your center and your activity, because I'm sure just by reading at the title that there are lots of possible links that we should exploit. So, Julian, if you would like to start sharing your screen, you're most than welcome. Yeah? And while you do that, I do the usual reminder to the participants to please use the Q&A facility to ask questions, and maybe towards the end of the talk you can raise your hand and we will give you the rights to ask the question in person. So, Julian, thank you very much. Over to you.
Thank you. Thank you. Thank you very much for the invitation. Colleagues, I hope you can see the presentation.
Yes, perfect. Thank you.
Perfect. Francesco, when we tested this earlier, I said, well, what happened to the biltong? And I explained to him that I did this talks in 2019 to a group of astrophysicists in Kimberley. And at that talk, I started by distributing biltong to the participants, the sliced packets of biltong that you can buy in any supermarket. And in the middle of the talk, I explained what we had done using DNA forensics to find out what was in the packet of biltong, packets such as the one that they'd just eaten. And we had found some quite interesting fragments pieces that we were able to identify, including kangaroo and mountain zebra. Obviously, distributing biltong is not possible in this environment, and in fact, butternuts actually better illustrate my point for this particular presentation. So that's why the presentation today is big data, blockchain, and butternuts. So I'm going to try and do the following in this presentation. First, just give you a quick introduction to our Center of Excellence in Food Security, which is located just down the road from you at the University of Western Cape. Then I'll talk about the food system problem more broadly. This is the food system problem that confronts the world at the moment. Then zoom in onto the South African food system problem, which we describe as a paradox. I'll describe what we refer to as our place-based living laboratory, where we can get to the butternuts and find out what butternuts have to do with this. And lastly, I want to ask the question, well, how can theoretical physics and computational science contribute to perhaps solving some of the issues which I'm raising during the presentation? So our Center of Excellence is a second generation Center of Excellence that was established by the DSI and the National Research Foundation in 2014. Second generation in that we are just 8 years old now. We come up for our final review in the course of this year, and then we'll see whether or not we'll be funded for another 5 years. The center is hosted at UWC and co-hosted by the University of Pretoria. It's very multidisciplinary, so we span everything from humanities through to molecular biology. Currently, we've involved about 100 researchers, and at any one time we usually have about 130 students and fellows that are funded by the Center of Excellence. It's a hub and spoke model, so a hub at UP and UWC, and then the spoke are the 28 institutions, which include Stellenbosch University and a range of other institutions both in South Africa and outside of South Africa. We're perhaps a little different from other centers of excellence in that some of our collaborating partners are civil society organizations, such as the WWF, and we also have collaborating agreements with some local authorities, including the Breda Valley municipality, where our living lab is located. So let's get some definitions out the way. The first is just to understand what we mean by food, and I've given you the definition here from the Codex Alimentarius. This is compiled and managed by the Food and Agricultural Organization. And what's important in here is that anything that is used in the manufacture or preparation or treatment of food is categorized as food. So this is the stabilizers that are used to be able to allow us to have highly processed food. Below that, I've just mentioned the differences of the kinds of food that we get, whether raw, processed, and say something like a loaf of bread is considered a processed food, or ultra processed. Ultra processed is currently in the media quite often because it's been linked to diet-related non-communicable diseases such as overweight and obesity and hypertension. They're the kinds of snacks that humans are very fond of, made from substances that are extracted from foods, various kinds of fats and starches, and they would contain additives and artificial colorings, flavorings, or stabilizers. So not intrinsically bad, but associated with non-communicable disease problems. Agri-food systems, which is the focus of what I'm wanting to look at, is defined on the right over there, which is the range of actors that are involved right the way through all aspects of the food system. And this is again an FAO definition. So the world agri-food system produces about 13.5 billion tons of food per annum. And this is used to feed the population of the world, the 8 billion people. And 8 billion people require about 74 trillion kilojoules per day. So that just gives us some sense of the scale of the food system. The diagram on the right is now being used by many authorities who are concerned with analyzing food systems. It sees the food system as comprising a set of drivers that impact upon the institutions, that in turn impact upon the core food system. There are a set of activities which can mitigate or intensify the outcomes of the core food system, and we have a set of food system outcomes. The drivers are often systems themselves, such as hydrological systems. There are also factors such as the political economy, demographic drivers, social-cultural drivers. So these then impact upon the institutions. And I tend to think that a center of excellence, or in fact a national institute, is one of the institutions that can have some bearing, that can influence the core food system. The core food system itself comprises food value chains, the business end of creating food, and food environments, the space within which we acquire food. Traditionally, we've often thought about food system outcomes as being food and nutrition security. In other words, having enough calories to be able to survive. But more recently, the OECD and others now think about food system outcomes as being not only food and nutrition security, but also the urban and rural livelihoods that depend upon food, as well as the environmental sustainability of the food system. So the idea here is that these triple challenges, these three possibly competing interests, have to be met by the core food system. Just to drill a little bit further into that, so we've got the tools to be able to follow the rest of the presentation. So again, on the left-hand side here, I've opened up what food value chains comprise of. So this goes from the upstream inputs, the seeds, the fertilizers, finance and knowledge, the actual production of food itself, how that food is then transported and ultimately then processed, the midstream of the food of the value chain, the milling, the drying, packaging, and so forth. Then how those are traded through markets, through wholesalers and cooperatives, and then eventually down to the downstream of the food system, which are the shops, both formal and informal, supermarkets, restaurants, and ultimately the consumers. On the right-hand side are the aspects of the food environment. This includes the policies that are adopted by government as well as by the private sector, and the kind of infrastructure that is available whereby people obtain their food. That includes things like shopping malls or development corridors, which try and promote the activities of small-scale food traders and restaurant activities. And ultimately, a lot of this is driven by the culture, the kind of food that people like to eat, and the ways in which they like to acquire their food. Okay, so that then very quickly gets us through what a food system looks like and its different components and the kinds of activities that take place both within the value chains and within the food environment. we've spent some time trying to understand what is a food system problem. And it's a quite unique and quite interesting problem. Firstly, it is the result of both private and public action. Private meaning the farmers, the consumers, the industrialists that are involved in processing food, and public action meaning the ways in which governments try and regulate the food system, the laws that are applied by all levels of government, from national right down to the provincial bylaws that determine whether a trader can operate from a particular street corner or not. And then also the action of international organizations such as the World Trade Organization, World Bank, the European Union, and so forth. This makes it an impure public good in the language of economics. A public good which has got both attributes of a private good and a public good. Public goods are usually subject to different forms of collection action problems. In other words, when people try and combine or compete to be able to get access to a resource, they will then need to collectively act to try and reconcile those differences. A good example of a public good is something like a park, and the collective action then is how do we agree upon the use of that park, how often we go to it, whether we litter it, whether the park is crowded or not, how we treat the plants. All of those are the kinds of things that need to happen for that public good to survive. But it also means that the food system is characterized by processes that are subject to market imperfections. So in other words, the price signals that you find in the market for different aspects of food outcomes may conceal the direct costs, the opportunity costs of mismanagement, and the integrity of the product. So again, let's go back to that idea of a park. The opportunity cost of protecting a park is what the land could have been used if not for recreational purposes, but also if some people litter or disturb plants, we're not able to see that translated into a price signal that determines whether or not that park is properly managed. So they make for quite complicated problems when trying to deal them through economic markets. It then means that those price signals that we do see to bring about market efficiencies operate poorly. Again, if we were to think of an example, if you are thinking about a factory that produces olives, if that factory releases the soiled water into a river, they will not necessarily bear the costs of that. That will happen downstream. Equally, a factory that is producing ultra processed food that results in diabetes, if consumed too far, does not itself bear the cost of that product. The net result of this is that stakeholders in a food system, although may be faced with a common concern, those food system outcomes that I talked about earlier, fail to find ways of acting together due to their different and competing interests. So the kinds of collective action problems that we talk about in economics are problems of how to coordinate the response to the market, to the problem, problems of cooperating, the inequality that lies between the different stakeholders, the fact that solutions may be unstable even once agreed upon, the fact that the problem may be so complex that we're unable to fully understand it, and the cost of gathering information to be able to understand the problem is too high. So we then rely on what we've experienced before. Again, in economics, we talk about bounded rationality. Problems of free riding, that some people may be able to benefit from the public good in question without having to pay the costs of generating it. Problems of finding and keeping agreements, and ultimately problems of fundamental uncertainty about causes of consequences. So those are the set of collective action problems that we think about when trying to deal with a food system problem. Now, I've always been very interested in what's now been referred to as implementation science. In other words, what happens when we actually try and implement a set of research findings to be able to come up with appropriate policies. Implementation science in the 1980s devised the notion of wicked and super wicked problems. They did this to try and distinguish this kind of problem from the tame problems, which would be more conventionally found in a laboratory essentially the difference between when you try and do something in a laboratory and when you try and do it in the messy framework of the world. This is the list of what constitutes a wicked problem. And I think there are a few which are particularly important. Number two, that there's no stopping rule. Essentially, you reach a solution when your money runs out or when your time runs out. It means that you then wind up with a solution that may not be optimal, but it's the best you can do in the circumstances. The next is that there isn't a clear set of solutions, and there's no set of permissible options. That there are many ways in which we can think about the problem and how to solve it, and many ways of thinking about how to explain that problem. When we try and solve a problem, it counts. The intervention that we do today may become the problem that we're having to deal with tomorrow. People like myself who are involved in the policy world are aspirant solvers of the problems, in many ways often become culpable for our solutions. The last three are what some have called a super wicked problem. That those that are causing the problem are also seeking to provide the solution. And the one at the end, which I think is particularly important in the current moment, time is running out. So what does that do to our issues of trying to understand food system problems? Well, the elephant in the room is that when complexity bumps up against evidence-based decision-making, we run the risk of making poor decisions because our algorithms are not well developed or the data which we're putting into those algorithms is poor. It means that in many ways, we often come up with bogus evidence-based decision-making, which we can claim this decision was driven by science, when in fact it may be driven by your biases and the assumptions that you made in building your database. Okay, so I've whistled through the notion of a food system. I've tried to quickly go through what a food system problem is and try to put that in a conceptual framework which allows us to recognize the kinds of problems and the nature of those problems and their solutions. And let's now go to what is the South African food system paradox. So this summary is derived from a recent exercise that was undertaken by the Food and Agricultural Organization, the European Union, CIRAD, which is the French Agriculture Research Center, and the Center of Excellence that I am the director of. It was done in preparation for the UN Food System Summit that happened in September last year. So essentially, I'm here very briefly summarizing a lengthy document and several months of work. The paradox is that South Africa is an upper middle income country. We produce enough food, we have a positive food balance, and we have the capacity, the financial resources to import food when we need. We have a globally competitive science and innovation system. We have a sophisticated food policy. We produce 58 million tons of food per annum in order to feed 60 million people. So we actually produce sufficient food to feed our population. Despite that, we have experienced poor food system outcomes. We have what is referred to as a double burden of food and nutrition security, which means that we have undernutrition, people aren't getting enough to eat, and overnutrition. Some people are eating too many empty calories. It means that we then have a prevalence of obesity in South Africa of around 60% of adult women, one of the highest in the world. Our natural environment is deteriorating. We have a highly concentrated food sector with small numbers of large food businesses. We have strong territorial imbalances often between the former homeland areas and the former areas that were designated for the white population. And this has been exacerbated by global processes of concentration. And finally, we have massive unemployment problem, and our rural areas are marginalized. The single graph, I think, sums up the bottom line with South Africa's food system problem. We have Africa's most comprehensive social protection program with our old age pension, our child support grant, a whole range of other activities that target children and target the nourishment of those children. And yet, unlike Brazil, which has the same strategies, has implemented the same strategies, or indeed Peru, which has also implemented the same strategies, our level of under 5 stunting, which is an indicator of chronic malnutrition, has remained unchanged for 2 decades. Brazil, however, has been able to cut their prevalence of stunting from 37% in the 1970s now down to 7.1%. So that, to me, sums up the idea of the paradox. This very busy picture is not for you to go into the detail, but the analysis that I described for the FAO came up with four key challenges, which is detailed in the report, and I have the link in the presentation, which I'll share. The issue of the constraints on the sustainable agricultural practices, the double burden that I've already mentioned, the impact of concentrated economic power in the food system, and the discrepancies between our food policy, and our food system's outcomes. The detail in the graphs show the linkages between different components of that problem and how they carry forward into the ways in which those problems are manifested, are repeated, and ultimately lead to food system outcomes. So it gives you a sense that we have done some systems analysis already to be able to understand the operation of the South African food system. Okay, so to change gear again. In an effort to try and deal with this complexity, our Center of Excellence has adopted what we refer to as a place-based approach to the analysis of food systems. This means that we have focused on two, what we call living laboratories, two territories in South Africa. One is the Breede Valley Municipality, which is just up the road from Stellenbosch, and the municipality which is centered around Worcester, and the other, which is in the Eastern Cape, is in Matatiele. We are furthest ahead with our work in the Breede Valley, where we've already mapped, and this is what you're seeing here, every food facility that exists in the Breede Valley. We've also undertaken household surveys. We are working very closely with the municipality to understand their development planning processes. And we're now starting to crowd in other research projects, which give us a very thick database of this localized food system. It's an interesting food system because the Breede Valley is a highly productive part of South Africa in terms of the production of food. Although it contains just 0.3% of South Africa's population, it contains 1% of South Africa's farms, 3% of South Africa's farm workers, and produces a whole range of foodstuffs in quite significant proportions, including butternuts. So down there, you'll see that the Breede Valley produces 6% of all butternuts that are produced in South Africa and contributes 7.5% of all butternut exports. Most people probably know the area for the 29% of South Africa's table grapes that it produces and the 34% of South Africa's wine grapes that's produced. The Breede Valley is also unique in that a very significant share of the land is arable. 45% is arable in the Breede Valley compared to 16% of South Africa. 91% of that land is cultivated and 65% of that cultivated land is irrigated, well above the norm for South Africa. The Breede Valley needs 1.6 billion kilojoules per day to feed its population, and that's going to cost about 1.4 billion rand per annum. Just for comparison, the agri-food sector in the Breede Valley earns 6.5 billion rand per annum already. Despite this, the paradox kicks in again. 27% of children in the Breede Valley are stunted. That's higher than the national average. We've used the work so far to map the food system in the Breede Valley. So these are maps that we've generated using the survey data that we've had. We've used techniques such as Bayesian inference statistics to be able then to link that back to areas where we have high levels of food insecurity, where we have high levels of multidimensional poverty. And the little diagram in the bottom right is a diagram that we shared with the Breede Valley municipality during the COVID lockdown, which indicated which were the likely hotspots for food insecurity due to the banning of the informal food trade that the South African government did back in April 2020. We're also mapping the climate change in the area, and the current project that we're working on tries to bring together the impact of climate change on that food system, where we're looking at things such as the increase of very hot days and heat wave days, as well as the impact of the erratic rainfall. You'll notice the red line there in the rainfall in the Breede Valley, which was the 2017 drought. Okay, so I hope I'm on time, Chair, and I've been trying to go through this quite quickly, but hopefully it's been clear. Now, what do butternuts have to do with all of this? So South Africa eats about 88,000 tons of butternut per year and exports around 18,000 tons. Mostly this goes to the UK and Netherlands. The Breda Valley grows about 6,200 tons per annum and exports of that about 13,000 tons per annum. Many of these butternuts are grown on the farm that you see in the top left, which is from Google Earth. It's extracted from the Breda Valley municipality. And if you've traveled on the road between Worcester and Robertson on the way to Swellendam, perhaps at the R62, you might have gone past this little stall on the right-hand side. That's the image from Google Earth. And down the bottom then, a photograph that I took. It's the Pampun style. So this sells every year. You'll see it with all its display of pumpkins. But it's also an important farming unit for producing butternuts, which they export through the Be Fresh, which is a storage facility that handles the export of butternuts, and that is located in Klapmuts. Butternuts turn out to be a pretty good vegetable. They contain a lot of energy, they contain a lot of vitamin A and vitamin C, and they're an excellent source of fiber, vitamin E, and a whole range of other micronutrients. So not only are they a good export crop, they're also a good foodstuff for poor people in the Breda Valley to eat. But as the director of Be Fresh remarks, it's easy to grow butternuts. It's not easy to grow export butternuts. Butternuts have been recognized as a superfood, in fact. And you'll see an article there from The Observer that tells us that Jamie Oliver even likes butternut, and it's been on the menu at Buckingham Palace. Much of South Africa's butternuts probably wind up being sold via Tesco in the UK, and you'll see a range of products which Tesco, in the ways in which Tesco sells butternuts, both fresh as paste or pulp, processed into pasta, frozen, and even extruded into gluten-free butternut fettuccine, which they say is GMO-free. But butternuts obviously are then a crop that have attracted attention around the world. A whole range of countries are now exporting butternuts to Europe, including the Ukraine, with Spain, who has not been a good friend of ours in the last little period, and I'll tell you about that in a minute, being the leading European producer, with a production of 160,000 tons, far more than South Africa. So butternuts could be a good crop for us. It's maybe something we might like to promote to the Breda Valley municipality. So what could possibly go wrong? Well, according to the National Department of Agriculture, rather a lot. So this is just a list from the NDA's brochure that's directed towards smallholder producers, telling them what might go wrong with butternut production. In addition to that very long list of natural hazards, I've added a few down on the bottom there on the right-hand side. Transit delays, such as the ports that would have been clogged recently with delays in the export of our citrus. Market gluts when too much is produced and the price falls. Phytosanitary barriers, such as the barriers that have just been put in place of South Africa's citrus exports, which have led to citrus being delayed in the ports, not to mention global pandemics and indeed war. So as Tia Diaga remarks, and Tia Diaga is the president of the Global Farmers Organization, the first thing that a farmer thinks when waking up is risk. Now we move towards where big data might fit in. We're now looking at a whole range of possible solutions to be able to address some of these hazards, and solutions that are indeed available even to smallholders. Often referred to as Food Systems 4.0, they include drones, water monitors, mini tractors. The one in the middle there is a device so that you can attach to your tractor so that you have precision guidance of your tractor. We can link to the Internet of Things and be able to draw data from all of these different sources into an enterprise management tool. We can do mechanical harvesting to be able to deal with the problems of damage to your harvest. And we can use radio frequency IDs to be able to track that food stuff, the containers, the packaging, right the way through. All of this can then lead to, again, the other item in my title, to blockchains where the data can be stored, it can be accessed, it can be regulated, and it provides a secure way which for people to be able to transact with using a food product such as a butternut. These technologies extend upstream and downstream. So in our innovation system, we now have tools which collect and manage large amounts of data when undertaking the DNA forensics that I spoke about earlier. When it comes to prime breedings and using technologies such as gene editing, again, huge amounts of information can be gathered there as we attempt to innovate and develop new crops. In the manufacturing process, both of the crop, but also the inputs, the picture on the left-hand side in the middle is a plant, that a production facility in Belleville that makes irrigation cables and uses advanced forms of data management to be able to identify flaws in the system. Smart containers, even smart shopping baskets, which is the one down the bottom there, a shopping basket that will tell you what's in your basket, how fresh it is and how to cook it. And obviously, finally, you can use your telephone and have smart packaging, which again tells you how to cook the food. These kinds of technologies have their fans. On the top right, I recently attended the agricultural salon in Paris, where President Macron makes an appearance every year. And there, as you see, big data is being espoused by him. And there's Eugene Blanche, the World Farmers Congress, again, who talks very enthusiastically about how we can use these technologies to better manage our food systems. Nearly finished, Chair. So we're having opportunities here. Well, obviously, more exportable butternuts, what might come if we adopt these technologies. But there's a range of other ones. We can improve livelihood outcomes. We can improve the sustainability outcomes by being much more precise about how we use harmful products and practices. We can improve food and nutrition security outcomes, including the consumer satisfaction, how water and sanitation and hygiene affect the utilization of the food, and to reduce the wastage of food. We can improve the management of food safety hazards. And this includes, for example, the listeria that we faced in 2019. Precision monitoring through the food value chains, precision monitoring through the food environments, critically building traceability, transparency, and accountability. And that includes for the externalities, the things that food producers might do that in the past, as I mentioned earlier, would be free riding. But then here we can, with greater tracking, we might be able to allow those that are remiss to be accountable for the externalities, the negative externalities that they produce. We can improve the predictive power for our technology, process, and system innovations, and ultimately we can promote transdisciplinary research, which is something I hope follows out of this seminar. And then there are challenges. The interface to be able to connect the Internet of Things, big data, the users and researchers is going to be complex. Harmonizing the different systems is also a complex problem to deal with. We need to figure out how to deal with privacy and security concerns. And this is, I think, for all of us at universities, become much more clear as we're having to deal with the Popeye Act. There are the politics of data ownership, transparency, intellectual property, and the risk of losing competitive advantage. There's a risk of a new digital divide, where smallholder agriculturists, small enterprises, the informal economy, and low-income consumers may not be able to access the technology, while those that have the correct devices are able to benefit disproportionately. The technological change may actually eliminate entire links in a value chain, and as a result, we could witness the loss of jobs. These tools may also result in increased market speculation, such as we had in the 2018 food price boom, as well as possible biosecurity hazards. There's even the question of whether food systems might run the risk of being weaponized. And finally, the last issue to deal with are the legalities, the social norms, and the ethics of of adopting such robotization and artificial intelligence technologies. So then, how can theoretical physics and computational science contribute? I think the first, to me, is the most important. For us and other disciplines, making sense of this complex system is extremely difficult, and we frequently lose our way. And so I'm not sure if the cartoon on the right is accurate, where it concludes that while liberal arts majors may be annoying sometimes, there's nothing more obnoxious than a physicist first encountering a new subject. I think that the fact that physicists are able to precisely think about complicated systems and how we might simplify that to be able to better understand them is an important contribution. I think we can also think about how computational science will facilitate better data sharing between disparate actors along food value chains and deal with those problems of confidentiality and anonymity that we're going to have to figure out. There's dealing with resolving the collective action problems that we deal with within the food environments, as well as remaining at the cutting edge of new data science opportunities. All of this, I think, can contribute towards filling data gaps throughout the food system and taming some of those wicked problems that I described earlier. And that's it. I hope I've been able to at least give you a whistle tour through the process of food system analysis, the kind of problems that we encounter. I've tried to use butternut as a way of illustrating what are some, if we were to concretize this down to a particular area and a particular product and a particular set of innovations, what might be some of the challenges that can be that will come up, and then describe some way in which the data science and theoretical physics could contribute. Thank you, Chair.
Thank you very much, Julian, for a fascinating talk that opens a new world of possibilities for engagement. Thank you very much.